Testing, testing. Do you guys hear me? Is it working? Sorry, my chair's loud. Still a few people that need to join. So as a reminder, this is the pre-calculus, so anyone can join, but just know that it's pre-calculus. First, you're a funny man. What the heck? Oh, there it is. Yeah, so it's been a couple funny things. First one, so I can't play any more music. I got hit with a, hey, you're playing music and someone owns it type of thing. And I was like, I totally forgot about that. I totally forgot that even if it's something subtle in the background that they're going to pick up on that. So no more music, unfortunately. But yeah, things are getting kind of crazier and crazier. You know, the at-home order that, you know, Gavin Newsom stated yesterday. My wife is now basically effectively laid off. You have no clue to where to find the worksheet. Okay, so if you went to the intro video that I made, Jazzy, but I'll show it right now. Here we go. You go to courses. You go to pre-calculus. Under class resources, you click that. And then under differentiated instruction, you click that. And here's all the DIs that we're going to be working on. So the current DI, the 63-2, it's that one right there. So the worksheet that you're probably clicking on is like right below the video. That was the old homework assignments that I've made. And I've tried to deactivate most of them, but I forget which ones are activated and deactivated. So that's probably why it's created that level of confusion. But this is where you literally can find all the DIs. So from that differentiated instruction, you just click that, and it's all of the DIs. Yeah, yay! But just know, and it might be a good idea to watch that intro video that I posted on Discord. If you click that learning doc, it has like every bit of instructions. You can fast forward through the intro video to the things that you need or don't need, so you wouldn't have to worry too much about that. But I think you're pretty much set up. I mean, you're set up on Discord. You understand I'm streaming. You now know how to find the worksheets, how to access the videos. I mean, that's pretty much it. So I think you're pretty much set anyways. So how are we all holding up? Are we doing okay? I know it's kind of like we're getting that like almost like cabin fever where we're just like stuck in our homes and it's like, I gotta do something. You know, I've been trying to go outside, walking the dogs, things like that, but it's definitely difficult since it's been raining, so it's been worse. It's all nice and sunny now, which is great. Let me link to the YouTube. The top recap question is what I usually go over to you guys as like, hey, remember this is what we did in the lesson, so it's not required. No. You just have to do what the DI is itself. So I'm going to talk about that very shortly. I just want to get a link to my YouTube. I had a little bit of a late start this morning just because my wife's job and because of the at-home, you know, that's a big question mark and things like that. So it was kind of a messy morning. Okay, please don't... Oh, yeah, you guys probably heard that. All right, post this in Discord. Link to the stream. Bam. Great. All right, so let's get started. I think I've given enough people enough time to kind of wake up. Probably some people are thinking, you know what? I could probably just tag along a little bit later, so that's all fine. So let's recap the video or the lesson. So we have the last lesson in polynomials, so 63.2. We, in the last lesson, defined what complex numbers are. It's the combination of real and imaginary. And basically, we're going to see these real and imaginary values within the polynomial. And so we started off with the fundamental theorem of algebra that says that whatever your degree is the number of zeros in your polynomial, including imaginary. So we just will say the phrase complex zero. And we know that it has at least one complex zero when it's going to be greater than or equal to 1. So it has to have at least that complex zero. And then we're able to factor it into complex numbers. And so I did an example here, and I'll do that in the recap in which we factored this. And we basically wrote it as, x minus or 0, and we had those complex zeros. Now skipping down to the non-real and irrational zeros theorem, all this says is that our complex numbers or irrational numbers, or irrational zeros, so like the square root of 5, they come in complex conjugates, meaning you'll always have these conjugate pairs. There'll be 2 of them. You'll never ever see an imaginary value in our polynomial by itself. There will always be the conjugate there. And it's powerful because it means it comes in 2s. And so that's when I went back to Descartes' rule of signs, and we said here, in this scenario, we counted it, and we had 4, 2, and 0 in terms of our possible positive zeros, and then we plugged in negative x into our function, and then nothing changed, and so therefore our possible negative zeros. And so filling out this chart, kind of going back to this, we said that if I had 4 positive zeros and no negative zeros, 2 positive zeros and no negative zeros, and no positive zeros and no negative zeros, well, this all has to add to this 4 right here. And so imaginary zeros will always come in conjugate pairs. So either there has to be 0 here, because 4 plus 0 is 4, 2, or 4. So these all have to add to equal 4. Now, because the imaginary zeros come in conjugate pairs, that's the reason why you count down by 2. So I know that I mentioned that you count down by 2 every time, and it was kind of like, well, why is it that we count down by 2? That's kind of weird. It's because of these complex zeros, these imaginary zeros, they come in conjugate pairs. And so that's why we count down by 2. That was loud. Discard. And then we just talked about the idea of being able to factor, and here are some of the zeros, and going through and factoring it. So let's go through and practice that. So my recap says find all the zeros of the polynomial, then factor it over real and complex. So if I have the x cubed plus 3x squared plus 4x plus 12, in factoring it, we have to do our p's over q's. So the factors of 12 over the factors of 1. So we get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So we have to test those zeros. Now, just looking at this one here, because it goes from positive to positive to positive to positive, that tells me that Descartes' rule of signs, there are no positive zeros. Now, like I said, this is something we should practice, but it's not necessary. It just saves us a little bit of time, and so in this instance, it's going to save me a little bit of time. And so I'm not going to try any of the positive zeros here. 1, 3, 4, 12. Now I already know that this isn't going to work. Okay, so that doesn't work, so let's try negative 2. Add straight down, multiply, add, multiply, add. Okay, so that's not going to work. Let's try negative 3. Add straight down, multiply, add, multiply, add, multiply, add. So that does work. So that means doing this division with my 0, it's x plus 3. And then this piece right here, remainder constant x squared, that gives me x squared plus 4. So now, this being x squared plus 4, I can set that equal to 0. Minus 4. Square root both sides, and I get x equals plus or minus 2i. So, everything's been broken down. Everything is factored, quote unquote, so to speak. There's nothing I can break it down even more. So, all I need to do now is just answer the question. So the first piece, it says find all the zeros, and I'm going to extend this. So my zeros are going to be negative 3, 2i, and negative 2i. So that's the first piece there. The second piece is factoring over real. That means what was the step right before I got a bunch of imaginary values. So this was a real number. So x plus 3. Now the moment that this x squared plus 4, that I broke that down further, it gave me imaginary. So that means that giving me these imaginary values, that was too far. So what was the step before it? That was this one. So then I'm going to say x squared plus 4. And then over complex, all you have to do is just take all of your zeros and just write x minus your 0. X minus your 0, and x minus your 0. And so those are the three different forms that we can express our polynomials. We can factor it over complex, factor it over real, and then these are all the zeros of the polynomial, both real and imaginary. Now, all imaginary zeros tell me is that it doesn't cross the x-axis. It's nothing we can necessarily plot. It's nothing that we can graph. I just know that it's only going to cross the x-axis once, and that's at negative 3. So that's kind of like the information that it gives me. So any questions with any of the steps there that I did so far before we kind of start working on the worksheet? And I'll look at the chat. I know it's an unavoidable delay. Okay, so I'm assuming that means that we should be good, since I didn't see any response. So let's, man, it's hard to find your mouse sometimes. So let's start working on this. There's a DI helper, so hopefully that's gonna to help out a little bit there. But let's say for number 1, we would have to go through and start trying to factor that. So we do our p's over q's, so the factors of 13 over the factors of 3. So that's going to give me 1, so 1 over 1 and 1 over 3. And then 13 over 1, and then 13 over 3. Nothing obvious about Descartes' rule of signs, so not worried about that too much. So now we can try our p's over q's to trying to get this through and factored. Now, just looking at this, I don't think 1 and -1 are going to work, just because 3, 13, or 16, or 13, so 10 or 16. I don't understand how 10 or 16 is going to give me a 43 and then back to the 13. So immediately looking at that, I probably know that the 1 and the -1 probably is not going to work. The fact that it turns from a 43 to a 13 tells me we're probably multiplying by like a third somehow, because you're getting from a big number to a smaller number. And so the way that we get a bigger number to a smaller number is usually through a fraction less than 1. So that's an idea. So maybe I'll try positive 1/3. So 3, -13, 43, -13. 3 multiply 1/3, so I get 1. So that gives me -12. Multiply, that gives me -4. And so that's going to add together and I get 39. 39 times 1/3 is 13. So it works. So, and literally that was just because, like I said, to go through that thought process there, there's the big list here. But 1 and -1, there's no way that I could get from a big number to 13. Like, that doesn't make any sense to me. The way that I'd get to like a 43 to a 13 would be by multiplying by a fraction that's smaller than 1. And so I just tried 1/3 first. I didn't know if -1/3 would work. No one knows. So I just tried positive 1/3. So that means here I got x minus a third, and then remainder constant x squared. So then I got 3x squared minus 12x plus 39. Now, whenever we have this fraction, that means that there's a number in common that I can factor out into that, and there's a 3. Makes it a little easier. And so that 3 goes into here. So 3x minus 1. And then I'm left with this x squared minus 4x plus 13. I don't see how the factors of 13 are going to give me that 4. So because they're not going to give me that 4, I'm probably going to have to do the quadratic formula, because it is a quadratic equation. And so, negative b plus or minus the square root of b squared minus 4 times a times c. And that's all over 2 times a. And so I just need to simplify that. So 4 plus or minus, I get 16. And then minus 4 times 13, 26 times 2. So that 54. Or 52. For some reason I had the 4 stuck in my brain. So 26 times 2 is 52. And so now I gotta just subtract that. So 16 minus 52. That gives me negative 36. Which is 4 plus or minus 6i over 2. And then the 2 divides into both, so I get 2 plus or minus 3i. So that's everything broken down. So now I just need to go through it. I need to answer the questions. So the first says, what are my zeros? 1/3. And then 2 plus 3i and 2 minus 3i. Then it says, what was my factorization over real numbers? So what was it before I got imaginaries? This. So that's going to be 3x minus 1 times x squared minus 4x plus 13. Real numbers just mean no imaginary. And then over complex means I'm allowed to have imaginary values. And so that's going to be x minus my 0. So that's my first one. X minus my 0. And then x minus my 0. And so there is my complete factorization there. Comments or questions on that one? I still don't even know how much of a delay it is. I think it's still 30 seconds. I don't think there's anything I can do about that. Okay. So even though there's multiple problems here, it's basically the same thing. P's over Q's, a couple of things that I'm noticing. For number 2, and maybe you guys can like put notes to yourself on this. For number 2, just remember that your P's over Q's, so it's going to be 1 over the factors of 9. So that means 1/3, 1, and 1 over 9. But when you go to divide, so let's just say if I do 1/3, remember the placeholder. So I have 9x cubed. I don't have an x squared, and then my x, and then 1, right? And then you'd have to go through and do that. Now, because of Descartes' rule of signs, everything's positive, so that tells me there are no positive zeros because the sign doesn't change. Not that everything's positive, but the fact that the sign doesn't change, right? And because the sign doesn't change, I know I don't have any of those. And then the reason why I would try 1/3 over 1 is you notice how it's getting smaller. So the way things get smaller is by multiplying by a fraction that's less than 1. Good question. So how did I get the 3x minus 1? So if I have the if I have the x minus 1/3 and then the times the 3, that 3 multiplies with that. So then you get 3x minus 3 over 3, which is 3x minus 1. Wow, that's a pretty big delay. My apologies. I didn't mean to move on so fast. There are stories of like things being throttled and stuff like that, so maybe it's being throttled. My doorbell. Does that answer your question, Jazzy? Oh, okay. Whew. Whew. I was worried that like there was like a massive delay or something. Let me see if I can go back to the settings. We good. Okay. So before I finish this one, I just want, like I said, just pointing out that you needed to have that 0 there, and you're going to go through everything like normal. For number 3, this is one of those that we just learned. So that x to the 4th plus 9x squared plus 20. This is the U-Substitution. So we would want to say u squared plus 9u plus 20. And then that would get factored. So u plus 4, u plus 5. So everything here is actually going to be ended up being imaginary, because you're going to get u equals negative 4 and u equals negative 5. So x squared equals negative 4. X squared equals negative 5. Square root both sides. And so you're going to get x equals plus or minus 2i. You're going to get x equals plus or minus root 5i. So there actually is, there is no like factorization per se. So my zeros would be 2i, negative 2i, square root of 5i, and negative square root of 5i. But the factoring over real, it's actually not factorable. So this would actually be your answer. The x to the 4th plus 9x squared plus 20. And then the complex, that's going to be x minus your 0, x minus ... I know, it's like this real estate right here is missing because of the webcam. So I always have to be aware of that. I'm just like thinking like, oh yeah, I can never write something here. I might accidentally do it, but I just can't. It's funny. Any questions on that one? Probably made all you guys on yawn too. Okay. So the rest of these are just, they're kind of long, but it's the same process, p's over q's, try and factor it out. So I'm just going to go ahead and move on. And so these are going to be very similar to what we practiced and worked on yesterday. And if you ever come across any of the questions on those, just remember, Discord, let me know. Send me a question. But like on I'll do number 8. Number 8 looks interesting. So I have z is 1 minus I root 3 and negative 1 minus I root 3. Okay, that's w. So if I said z plus w, so that's going to be 1 minus I root 3 plus, and then negative 1 minus I root 3. So the 1 and the negative 1 would cancel out. And then negative I root 3 and negative I root 3 would be negative 2 I root 3. So just because there's a root there doesn't change anything. It's all the same. if I had 1 over z, so that's going to give me 1 over 1 minus I root 3. So for us to be able to reduce that, we'd have to multiply by the conjugate. So 1 plus I root 3. And you multiply that top and bottom. So that's going to give me 1 plus I root 3 over, now we multiply that out and distribute, so 1 plus I root 3 negative I root 3 and negative, so negative positives and negative. I times I is I squared. Root 3 times root 3 is root 9. Root 9 is 3. So those are going to cancel out. So that's going to give me 1 plus I root 3 over 1. Now, I squared is negative 1. Negative 1 times negative 3 is positive 3. So I'm going to move that here. So I'm going to get 1 plus I root 3 over 4. So that's going to give me 1 over 4 plus root 3 over 4i. Because remember, we want to write it in the a plus bi form. That is the formal, proper way to write it. Any questions on those two dots? So I did dot number 1 and number 4. If you count it, going horizontally. Oh, I did write on me. I did it. I did it. Do. My apologies, Cole. There you go. I knew I was going to do it. It was like I hadn't done it until then. There we go. It was almost like I was predicting the future there. It was like prophecy. How you doing, Cole? Keeping it together? Doing well. You know, we're keeping it together. So that's all we can ask for right now. Next week is spring break. Enjoy staying in your house all the time. Yeah. I think the joke that I'm seeing on the internet is like it's an introvert's paradise. I don't know why. I mean, I'm a bit of an introvert, but I like going outside. All right, so let's keep going. So if I were to do, say, number 9, multiplying those together, so that would give me negative 25 times negative 4 is the square root of 100. Square root of 100 is 10. Number 12, I to the, I have like, there's like dust on my screen. So I to the 97th power. So I have to take that 97 and divide that into 4. 4 goes into 9 twice. 4 goes into 17 4 times. So my remainder is 1. So therefore, it's going to be I to the first power, which is just I. What does the square root of negative 11 come out to? So you're saying, what does the square root of a negative 11, like what does that equal? Is that what you're asking? Because if that's what you're asking, that should be square root of 11 I. The only thing that can come out is the negative, which is square root of 1 is going to be I. Dude, this delay. Okay, so yeah, then that should answer what you have. Okay, so I mean, I kind of went through everything. Are there any last questions? Because if you guys do come across something, you can always post it on Discord. More than happy to answer it. Kind of adds to the chat anyways on Discord, and probably other people have similar questions. So, are there any last questions? Because we're kind of done with this, so we can probably end a little bit early. I know that on your end, this piece right here will probably take a little bit longer. They are the polynomial problems. They do take a little bit longer. One thing that I will have posted is I'll call it like 64 or something. Like it'll say like 64 test, but I'm going to put it in the same folder. And it's going to be basically like a test. And it'll be a good way for you guys to go through and practice that. And maybe that would be something you could work on, over the break, just to kind of make sure. It's going to mock a real test. Maybe I'll count it as a real test. Well, I don't know. We'll see what happens. But it doesn't hurt you. It can only help you by going through that. So that's something that, I would please take a look at it. As whatever's happening in terms of, right now it's at-home shelter, so we're not allowed to leave our homes unless it's a necessity. So until something like that gets lifted, we don't know what's going to happen. So before I call it, any last questions? We good? I think it's kind of interesting. Like, I wonder if there's a delay on my chat. Because of me, like, streaming, there's a delay. But I wonder if it delays me the same thing with my chat. That'd be kind of weird. No problem, Hannah. Hope you're safe. Cool. All right, well, I'm going to go ahead and call it then. It doesn't seem like anyone has any last questions, so cool. Well, just if you come across something, go ahead and try and finish this. Might take you a little bit longer. It is a little bit longer of a lesson, or a DI. It's just these polynomials and how they break down. It takes a while. But just remember the P's over Q's, and you should be fine. If you want me to check your work, you can always upload it to Discord. If you have any questions, just ask me on Discord. I'm there. Other than that, stay safe. Please obey the rules. I know it's going to be spring break next week. Please, 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 please do not go on all these massive social gatherings, etc., etc. The idea for right now is for you to protect yourself, for you guys to be safe, and I hope you guys stay safe during this process. But other than that, have a good spring break, everyone.